Hello everyone and welcome to Van Tech Corner. It has been a long time, and in this video, let's take a look at the SQM QoS performance of the NanoPi R6S. For this test, the device will be running Friendly WRT because OpenWRT is not officially available. In the middle of the diagram in R6S, it is connected to my client PC with a 2.5 gigabit link speed. And then it is connected to my upstream router PC with a 2.5 gigabit link speed as well. Alright, so on this Xeon machine, I have torrent seeding to simulate all of the traffics via torrent. And I also have OpenSpeedTest as well as iPub3 server up and running. The other port of my router PC is connected to the upstream MikroTik router. So I will be running the test, setting SQM QoS values, and then try to ping and check the response time from my client PC to this 10.0.42.1 as well as the 172.16.9.1 because to my PC or to the NanoPi R6S, this IP is an external one IP address. So this is just my approach or just my option to check out or to simulate the bandwidth, the traffic. And please know that this is not an official way to benchmark the SQM QoS performance. So if you have any idea or you have any input, feel free to leave it in the comment section. Alright, so before we start with the test, let's have a quick check. So this is the current firmware versions of the R6S. It has been some day and I have yet to update it. So this is the current firmware release. Alright. So right now on the network interfaces, the device, we have OpenVPN and WireGuard VPN disabled. We are having GSCP client on the one port, and yep, this is the LAN port. So let's go to global network option and make sure packet steering is enabled. And then I will be going to network firewall and make sure I disable the full connect because I am worried that it may not work with SQM QoS. Alright, so let me save this one and then we will configure the SQM QoS. Before we enable SQM QoS, I will have a check first. 172.16.9.1 T. So this is the servers on the MikroTik. Alright, so you can see that it is a long way. So before I run the test, the ping response time is 1 ms. So if I run the OpenSpeedTest download, we are reaching 2300 Mbps, and right here we can see that the ping go to 8 and then 11 and 9 and 10, so something like that. Alright, and I believe the same should be for upload. We have the ping go up to 1875. Okay, so we can see that it fluctuates and there will be lagging due to this problem in real life. So let's go ahead and enable SQM QoS and check it out. Alright, so the interface name, make sure it is the correct interface. So I will go to network interfaces, and for my one port it is Ethernet 2. So network SQM QoS, interface name Ethernet 2, where is it? Right here, enable this instant. And for 2300, so I will put it 2300. Is it the correct one? Let's go and verify that. Google.com. Alright, so we are right. So it is 2300 and 2,350,000. Alright, so I'm more or less the same. So I will put this value and the same. Alright. So Q disables, let's say cake and piece of cake, and then the link adaptation. What is the correct one? So usually it will be Ethernet with overhead, and I believe it should be 42, which is a common value. Alright, so anyway, we just put everything like that and save and apply. Alright, so we all set, and now let's check it out. So this time, ping, alright, refresh, and let's go. We can see that with SQM-QoS enable, the R6S can only give out 1290 Mbps, and it keeps the ping response time stable, even though we have some problem with uploading. So we can see that for upload, we have a little peak right here. It's go to 16, but we have an overall stable performance. Alright, so more or less 1298. So let me go and check it out. Maybe let's go to 172.16.9.1, but this time I will ping 10.42.0.1.t. Let's check it out. Alright, so this time we are reaching 2200 Mbps, and we can see that the ping also increase, but slightly. Alright, it is around 1 of 2 only. Only one time it go up to 5 ms, but it is stable in overall. For upload, we start to see some differences. So the first test, we have slow download but high upload, and this time we have high download but slow upload. So I assume this router cannot handle 2.3 gigabit per second. So let me drop down the value to 1A. Alright, let's hit save and apply. Alright, very good. So let's go again. Alright, so it looks like we have a stable performance right now, and the ping response time only increased by 2 or 3 ms when we are reaching 1400 Mbps or 1500. However, I can see that for upload it is reaching 1600 Mbps, while my value is set to 1800. So there should be something wrong. Let me reduce the download and the upload maybe to 1500 Mbps. Alright, everything is up and running, and now let's check it out. Refresh the page and let's go again. So this time we have a stable ping response time. It is somewhere around 1 ms, which is really good. Let's see how it is for the upload. Still, for upload, we have 1400 Mbps as we set previously, and the ping response time somewhere nearby 4 ms. So it's never go beyond 4 ms. Alright, as you can see from here. So I can say 1400 or 1500 Mbps is the peaks of the SQM-QoS for the R4. So with this result, we can say that the NanoPi R6S can handle around 1.5 gigabit per second SQMQS throughput. Let me increase it to 160. And let's have a final check before we switch to torrent downloading. Alright, here we go again. Refresh and let's go. Alright, we are running 1300 Mbps with SQMQS value set to 1600 and the CPU is at around, let me see, 87% idle. So just now it was 70, and the ping response time so far so good. We only have a little problem for offload. Before move to the SQMQS test with torrent, I will be checking out throughput and the performance with iPub3, and I will try to run parallel stream at the same time to see if it actually works. We are having 1.36 gigabit per second iPub3 throughput, and the ping response time remains stable at 1 or 2 ms, and sometimes it does go to 2 ms. And right here we can see that the TX and RX is stable at 1700 Mbps. And we can see that the TX is now running 170 megabytes per second. This is more or less what we expected. So I'm not sure if I can trim to A, and this time I will try again. Alright, so we have a stream running at the same time, and still we have a stable ping response time, 1, 2, and 3, all going in the same line with no problem. Very good, a stable TX at 175 megabytes per second. So let me go ahead and stop this one, and I will try with reverse, and let's see. The same for reverse, a stable throughput at 175 megabytes per second and stable ping response time. I'm not sure what is the maximum rate I can do. I'm not sure if I can put it 16, but let's check it out. And I can see that it actually works. We have more or less the same RX, and the ping response is still stable at 1 or 2. Now let's take a look at the SQMQS performance of the NanoPi R6S when we're downloading torrent files. So right here I have set up 3 torrent seeding machines to simulate the traffic from the one side, and then on my client side I will have one PC up and running. So the connection is 2.5 and 2.5 gigabit, and I want to maximum the throughput of the R6S. Alright, so the expected throughput for the SQMQS value of 1500 Mbps is 187 megabytes per second. Alright, so let's go and proceed with the test. So this is Beamon, and right here I have monitored the Ethernet 0, which is the one interface. Now I will try to ping the upstream router at 172.16.9.1, and I will start a torrent download from my PC. Alright, so I will press the start, and let's see what is the speed that we got. Alright, so immediately after I press start, we are downloading at 167 megabytes per second. You can see from here it is 175 megabytes per second, and the ping response time remains stable as 1 ms. Alright, so the download is finished, and now let's stop the ping. So if you take a look at the ping response time, the minimum is 0, the maximum is 1 ms, and the average one is 0 ms. Alright, so what I'm going to do is that I will open the folder destination 1 delete all the files, and then I will try to ping. This time I will try to ping 1.1.1.1 for example, and in the normal condition we have around 22 to 24 ms. Alright, so let me go ahead and force recheck, and let's see if we have any problem with the latency. And yep, we start the download again. So we are playing at 56 megabytes per second, and the ping response time is still on a stable result at 24 or 23, and it's never increased beyond 25 or 26. So I can say that we have a really stable SQM-QoS performance with the NanoPi R6S at 1.5 gigabit per second. So far, we have gone through some of the tests with the NanoPi R6S when it comes to SQM-QoS performance. And my conclusion is, if you want a stable ping response time, both upload and download, then you should set SQM-QoS value to 1.5 gigabit per second or 1500 Mbps. However, from my test, I can see that the NanoPi R6S should be able to handle SQM-QoS download or ingress up to 2000 Mbps or 2 gigabit, and for the upload you should stay around 1.5 to 1.6 gigabit per second. If you go to 2 gigabit, there will be a slightly ping increase during the torrent uploading or during the file uploading when we are reaching 2 Gbps. So that will be all for this videos, and I hope it will be useful for you. Thanks for watching, and see you all in the next one.